5 kilometers of solid ice. Temperatures cold enough to freeze your lungs in seconds. Winds fast enough to flip a truck. Antarctica is the kind of place most living things avoid entirely. And yet, right now, some of the most powerful nations on the planet are spending billions of dollars to get there. Not to visit, not to study penguins, to stake a claim on something buried so deep, so old, and so valuable that it could reshape the entire world order. China just opened its 5th research station on the continent. A 6th is already planned. Russia is quietly running surveys across Antarctic waters, mapping things they have not publicly explained. And a global treaty that has kept Antarctica off limits for over 60 years is heading toward a review date that changes everything. That date is 2048. What is under the ice? Why does it matter so much? And why are the world's biggest powers moving so fast to get there before that deadline hits? If you find yourself asking those same questions about the world's biggest mysteries, hit like and subscribe. We cover exactly this kind of story every week. Now, to understand what is really at stake, we have to go under the surface. And what we find down there is going to completely change the way you think about the bottom of the world. The world's most underrated continent. Most people think of Antarctica as a giant frozen wasteland sitting at the bottom of the world. Nothing lives there. Nothing happens there. It is just ice. And if that were true, nobody would care about it. But China cares. Russia cares. The United States cares. And the reason they care starts with just how enormous and how full of resources this place actually is. Antarctica is the 5th largest continent on Earth. It is bigger than the United States and Mexico put together. It holds 70% of all the fresh water on the planet, locked inside an ice sheet so thick it would completely bury the entire Alps mountain range. The average thickness of that ice is about 2.5 kilometers. In some spots, it goes nearly 5. On the surface, temperatures drop to -90 degrees Celsius. That is so cold that exposed skin freezes in under a minute. Winds can hit over 300 kilometers per hour. In winter, some parts of Antarctica go 4 straight months without a single ray of sunlight. And yet, life is everywhere. Not just penguins and seals on the surface. Life exists deep under the ice, in total darkness, in water that has not touched the outside atmosphere in millions of years. Creatures no one expected to find, surviving in conditions we once thought were impossible for anything alive. China's scientists have been studying exactly these kinds of extreme environments, and what they are learning is directly connected to what makes Antarctica worth the extraordinary cost of being there. Here is something that puts the scale in perspective. The ice sitting on top of Antarctica is so heavy that it has literally pushed the continent down into the Earth's crust. The bedrock beneath parts of West Antarctica sits more than 2 kilometers below sea level. Not because the ocean is there, but because the weight of the ice above has pressed the land down like a thumb pushing into soft clay. If you removed all the ice tomorrow, the continent would slowly rise back up over thousands of years. The land remembers what it was before the ice came, and that is just what we know about the surface and the rock directly beneath it. The real story is not about ice you can see or rock you can measure from satellites. It is about what has been building up inside all of that ice, layer by layer, year by year, for over 1 million years. A record so valuable that it is one of the first things China pointed to when justifying its massive expansion across the continent. That record is what makes Antarctica irreplaceable, and it starts at the very top with something as simple as snowfall, a library buried in ice, and the fire beneath it. China's polar scientists did not just show up in Antarctica to build stations and wave a flag. They came for information, specifically for the kind of information that is locked inside the ice itself and cannot be found anywhere else on Earth. When snow falls in Antarctica, it does not melt. It just piles up, year after year, century after century. Each new layer of snow pushes down on the one beneath it, compressing it slowly into solid ice. Here is what makes that remarkable. As the snow compresses, tiny pockets of air get trapped inside. Little bubbles sealed in like time capsules. Each bubble holds a sample of the atmosphere from the exact year that snow fell. Scientists drill down into this ice and pull up long cylinders called ice cores. The deeper the core, the older the air inside. The oldest continuous ice core ever recovered was drilled from nearly 3 kilometers down. The air bubbles trapped inside are about 1.2 million years old. That means scientists can crack open a piece of ice and analyze air from before modern humans ever walked the Earth. Inside those bubbles, they find carbon dioxide levels from ancient climates, methane concentrations from eras long gone, volcanic ash from eruptions that happened before any written history existed, temperature signals that tell us what the world was doing hundreds of thousands of years ago. This is how we know that when woolly mammoths were walking across Europe, carbon dioxide in the atmosphere was roughly half of what it is today. This is how we know the Sahara was once a green, wet, forested landscape before it dried into a desert. Antarctica recorded all of it, silently, in ice. Think of it like the world's most detailed diary, written 1 page per year for over 1 million years straight. China is drilling deeper into this diary than most countries have ever attempted. Their ice core programs are producing data about ancient climates, ancient carbon cycles, and ancient atmospheric conditions that feed directly into the kind of large-scale resource modeling you do when you are trying to figure out where oil and minerals formed millions of years ago. And here is the problem for the rest of the world. If global temperatures keep rising and that ice melts, the diary is destroyed forever. There is no second copy anywhere on Earth. Whoever reads the most of it before it is gone has a significant advantage. But as extraordinary as the ice archive is, there is something else happening deeper down that almost nobody talks about. Because most people assume that beneath all that ice sits frozen, silent, dead rock. What actually sits beneath parts of West Antarctica is dozens of active volcanoes. They cannot erupt the way normal volcanoes do. The weight of the ice pressing down from above is simply too great. Instead, the heat builds slowly below the surface, melting the base of the ice from underneath, quietly carving hidden chambers of water and steam in complete darkness. This geothermal heat is one of the reasons parts of West Antarctica are losing ice far faster than early climate models predicted. Scientists originally assumed the ice was only being affected by warming temperatures above, but the ice is also being eaten from below, and that factor was missing from the calculations for years. One of these volcanoes, Mount Erebus, breaks through the surface near the coast. It is the most southern active volcano on the planet. Gases from its vents carve warm caves inside the surrounding ice. Inside those caves, scientists have discovered mosses, algae, and DNA sequences that do not match any known species anywhere on Earth. Life forms never before cataloged, surviving in a warm, hidden pocket inside one of the coldest places in the world. Mount Erebus also carries a more human kind of history. In 1979, Air New Zealand Flight 901 flew directly into its slopes, killing all 257 people on board. The terrain was unstable. The ice was always moving. A full recovery was never possible. Parts of the aircraft and possibly human remains are still believed to be entombed beneath the glacier today, preserved perfectly by the cold, locked in exactly where they fell nearly 50 years ago. Antarctica preserves everything: the ancient air, the ancient rock, the very recent tragedy. And the heat from those buried volcanoes does something else that is critically important to understanding why China and Russia are so focused on mapping the geology down here. That heat melts ice from below, and that meltwater goes somewhere. It does not just disappear. It flows into one of the most extraordinary hidden systems on Earth, a system that is directly connected to the resources nations are positioning themselves to eventually claim. Rivers in the dark. Drop more than a kilometer beneath the surface of Antarctica, and you reach the place where rock meets ice. In most people's mental picture, this is where things stop. Frozen rock, frozen ice, nothing moving. But water is moving down here, lots of it. And China's polar research teams have been spending considerable resources trying to understand exactly how. Beneath Antarctica, spread across the entire continent, there is a vast hidden network of underground rivers and lakes. They have been there for millions of years, running in complete darkness under crushing pressure, completely cut off from the sky above. Some of these lakes are enormous. Lake Vostok, sitting beneath East Antarctica, is 240 kilometers long and 50 kilometers wide. That is bigger than the entire country of Belgium. It has been completely sealed beneath the ice for somewhere between 15 and 25 million years. No light has ever reached it. No outside air has touched it. It has been sitting in perfect darkness, under more pressure than most submarines can handle, for longer than our entire species has existed by several million years. And it is not alone. Scientists have identified nearly 700 subglacial lakes scattered across Antarctica. Some are connected by underground rivers that flow through gaps in the bedrock. What happens in these systems is one of the most dramatic things occurring on the planet right now, entirely out of sight. Water fills one lake until the pressure reaches a tipping point, then suddenly releases, flooding into neighboring channels and traveling hundreds of kilometers underground in just a few days. Billions of liters of water moving through solid rock in the dark. When these floods happen, the ice sheet above them physically moves. Satellites have recorded the surface of Antarctica rising and sinking by several meters as the underground pressure shifts beneath. We have barely explored any of this directly. If you added up every single spot where a human has physically made contact with the ground beneath the Antarctic ice, the total area would fit inside a basketball court. China is aware of this gap, and part of the reason they are investing heavily in electromagnetic survey technology is to map what lies beneath without having to drill everywhere. These systems send signals through kilometers of ice and rock, bouncing back information about what is frozen, what is liquid, and what is flowing far below. Mapping those underground rivers and lakes tells you where water is moving, where heat is concentrated, and critically, where mineral-rich fluids have been accumulating for millions of years. It is scientific research on the surface and geological intelligence at the same time. But sometimes, this hidden underwater world finds its own way to the surface without any technology needed at all. In one valley in East Antarctica, a deep red liquid seeps out from the base of Taylor Glacier and stains the ice beneath it like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, they had no explanation for the color. Some suspected algae. But algae needs sunlight, and this water was coming from hundreds of meters inside solid ice. What it actually is: ancient brine water, more than twice as salty as the ocean. That saltiness keeps it liquid even at -5 degrees Celsius. It has been sealed beneath roughly 400 meters of ice for millions of years. When it finally seeps out into open air, dissolved iron in the water reacts instantly with oxygen and turns bright red on contact. What spills out looks like blood, but it is something far more interesting. It is a direct delivery from a world that has been running silently beneath the ice for millions of years, carrying iron and nutrients from deep in the rock toward the ocean. The iron concentration in water like this is one of the things China's survey teams look for when mapping subglacial chemistry, because iron-rich geological zones are often associated with the kind of mineral deposits that make a location worth revisiting. And when that nutrient-rich water finally reaches the Southern Ocean, it triggers something on a scale that is hard to believe. It feeds massive blooms of microscopic plant life. Those blooms feed krill, tiny shrimp-like creatures that swarm in numbers beyond counting. Those krill feed blue whales, the largest animals to ever exist on Earth. In the 20th century, over 360,000 blue whales were killed in Antarctic waters in just a few decades. Their populations collapsed by 97%. They are slowly recovering now, but their entire survival depends on the health of an ecosystem that begins not in the ocean but under the Antarctic ice. From the bedrock, through hidden rivers, into the Southern Ocean, up through the food chain to the largest creature alive, everything is connected. Pull one thread, and the whole system feels it. But to understand what countries are actually trying to position themselves to control, we need to go all the way down to the bedrock itself. Because what is sitting under the ice is not just rock. It is one of the most geologically rich and unexplored territories on Earth, and it is the reason China's Antarctic expansion has been accelerating with a very specific kind of focus. The continent nobody has seen. Scientists have created a detailed digital map called BedMap 2. Using millions of aerial and satellite measurements, it shows you what Antarctica would look like if you removed every single drop of ice in one moment. What appears is not a flat, frozen slab. It is an entirely different world that nobody has ever seen. And it is exactly the kind of world that makes geologists and governments very interested. Entire mountain ranges lie buried in complete darkness. The Gamburtsev Mountains stretch across the interior of East Antarctica, with peaks rising thousands of meters above the surrounding terrain. No explorer has ever stood on their summits. No photograph has ever captured them. They exist only in data gathered from signals bounced through ice. They have not seen light in millions of years. Nearby, Denman Canyon cuts through the bedrock and drops more than 3.5 kilometers below sea level. That makes it the deepest land canyon on Earth, far deeper than the Grand Canyon, and it is completely invisible unless you strip away the ice in a computer model. Ancient river valleys run between these buried mountain ranges, preserved exactly as they were tens of millions of years ago before Antarctica ever froze. Fossilized pollen and ancient root systems still exist in the rock, leftovers from when Antarctica was a warm, green, forested land sitting much further north as part of a giant supercontinent called Gondwana. The trees are long gone. The impression of them in the rock is still there. Then there is a structure so large and so strange that scientists are still arguing about what it is. In East Antarctica, buried beneath the ice, there is a circular feature about 300 kilometers wide. It creates a gravitational signal so strong that satellites can detect it from space. One leading theory is that it is the scar left by one of the largest asteroid or comet impacts in Earth's entire history. Another is that it formed through deep geological processes in the crust. No one has drilled down to it. No one has seen it directly. But whatever it is bigger than most countries, and it has been sitting under the ice, untouched, since before humans existed. Now here is the part that makes all of this geopolitically explosive, and the part that explains precisely why China has been building stations, running surveys, and investing in polar logistics at a pace that has no parallel in the history of Antarctic research. Antarctica shares the same deep rock formations as South America, Africa, India, and Australia. All of those continents were once attached to Antarctica as part of Gondwana, hundreds of millions of years ago. And every single one of those continents is loaded with coal, oil, iron, copper, gold, and rare earth minerals used in batteries, electronics, and the technology that powers modern economies. Rare earth minerals deserve a special mention here. They are the materials inside every electric vehicle battery, every smartphone, every advanced military system, and every renewable energy installation on Earth. China currently controls roughly 60% of the world's rare earth production and an even higher share of rare earth processing. Understanding the geology of Antarctica, knowing where those deposits are before anyone else does, and being positioned to access them when the rules change, is not just an economic advantage. It is a form of strategic leverage that could define the balance of power for the rest of this century. Surveys already suggest vast deposits of oil and gas beneath Antarctic waters, along with mineral concentrations on the continent itself that could be worth tens of trillions of dollars. And right now, in 2026, every bit of it is legally untouchable. But that legal protection is not permanent, and the clock counting down to when it can be challenged is already running. The race before the deadline. In 1959, 12 countries signed the Antarctic Treaty. It declared the continent a zone for peace and science. It banned military activity. It suspended all territorial claims that countries had been building for decades. And in 1991, a protocol was added, specifically banning mining and resource extraction. For decades, it held. But buried inside the text of that environmental protocol is a clause that most people have never heard of. Starting in 2048, any member country can formally request a review of the mining ban. If enough countries vote to lift the restrictions, resource extraction in Antarctica could become legal. 2048 is roughly 22 years away. That sounds distant, but building permanent, year-round infrastructure in one of the most hostile environments on the planet takes decades. Establishing a legal presence that carries weight in treaty negotiations requires continuous, long-term operation on the ground. Conducting geological surveys that tell you exactly where to drill and for what takes years of quiet, methodical work that has to begin long before any vote ever happens. Which is exactly what is already underway, from multiple directions at once. China opened Qinling Station, its 5th Antarctic research station, in February 2024. It was built faster than most expected and equipped for year-round operation in extreme conditions. A 6th station is already in planning, proposed for a location called Cox Point. Each new station expands China's ability to operate across more of the continent, gather more data, and maintain a presence through the brutal Antarctic winter when most countries pull back entirely. China has also been investing in new polar icebreaker ships, aerial survey technology, and deep ice mapping programs that go well beyond what a purely scientific mission would require. The pattern is clear when you look at where the stations are being placed. They are not clustered in one area. They are spread out to maximize geographic coverage of the continent. The same approach you would take if you were trying to establish the broadest possible presence before a legal review. Russia has been running extensive seismic surveys in Antarctic waters, using the same methods the oil and gas industry uses to locate underground reserves. Russia holds some of the largest pre-existing territorial claims on the continent, claims that were frozen by the treaty but never formally given up. Their survey activity has been concentrated in areas where those historical claims overlap with regions that geological data suggests are mineral-rich. The United States operates McMurdo Station, the largest research base on the continent, and has significant infrastructure built up over decades. But the U.S. Antarctic program has been dealing with aging facilities and budget pressures that have slowed modernization. The pace of new investment from China and Russia is outrunning the pace of upgrades on the American side, and analysts who track polar geopolitics have been watching that gap widen for several years now. Here is the principle that makes all of this matter. Under international law, presence counts. Countries that have been operating continuously in a region, that have built the infrastructure, collected the data, and demonstrated the capability to work there at scale, carry far more weight in any future negotiation than countries that show up after the fact. Every new station is a quiet, legal move in a game that will not officially start until 2048. But by the time it officially starts, the positions will already be set. The treaty does not expire. That is important to say clearly. But the window to challenge its most critical protections opens in 2048. And when you have spent 2 decades building the most extensive presence on a continent, sitting on top of what could be the largest untapped resource deposit on Earth, that window looks very different from inside than it does from outside. What makes the stakes even higher is not just the minerals or the oil. It is everything else that depends on Antarctica staying exactly as it is, and the consequences of getting this wrong are far bigger than most people realize. What happens if we get this wrong? Take a step back from the stations and the surveys and the treaty deadlines for a moment, and look at what is actually on the line if the competition for Antarctica stops being managed and starts being contested. The ice cores drilled from Antarctica contain a continuous atmospheric record stretching back 1.2 million years. There is nothing else like it anywhere on the planet. If that ice melts, or if industrial activity on the continent disrupts the layers before they can be fully studied, that record is gone permanently. Not damaged, not reduced, gone. Every question scientists have not yet thought to ask about the history of Earth's climate will go unanswered forever. China's own climate modeling programs depend on data gathered from Antarctic ice cores. That is part of why Chinese scientists have been drilling deeper than most, because they understand better than almost anyone what gets lost if the archive disappears. The subglacial lakes, especially Lake Vostok, have been developing in complete isolation for tens of millions of years. The microbes living in those lakes have had no contact with the surface world for longer than our species has existed. Scientists believe they could carry biological adaptations and chemical processes completely unknown to science. Beyond pure discovery, these environments are the closest natural comparison we have on Earth to places like Europa, one of Jupiter's moons, which has an ocean sealed under ice, just like Lake Vostok. Open that sealed system to contamination through industrial activity, and the opportunity to study it is gone. China has actually been among the leading voices in proposing protocols for accessing subglacial lakes without contaminating them, because the scientific value is something their research institutions are deeply invested in preserving, even as the geopolitical competition intensifies. The connection between the subglacial drainage system and the Southern Ocean food chain is not a background detail. It is the foundation of one of the most productive ocean ecosystems on Earth. The iron and nutrients that blood falls carries out from beneath the ice are part of a delivery system that has been running for millions of years. Phytoplankton bloom, krill multiply, and every animal up the food chain benefits. Blue whales, already recovering slowly from near extinction, depend on krill populations that depend on that nutrient cycle staying intact. Disrupting the bedrock through mining activity would send consequences through that food chain in ways that are genuinely hard to reverse. And then there is the ice itself. Antarctica holds enough water that if it fully melted, global sea levels would rise by roughly 60 meters. Every coastal city on Earth would be underwater. That is an extreme scenario, and it would take centuries to play out fully. But West Antarctica alone holds enough ice to raise sea levels by several meters, and it is already destabilizing faster than predicted. Adding industrial activity to an ice sheet already under stress adds pressure to a system that has less margin than most people realize. The Antarctic Treaty has held for over 60 years because every country that signed it found that cooperation served them better than competition. That cooperation produced the ice cores, the subglacial lake discoveries, the satellite mapping, and the climate models the whole world depends on. 2048 does not have to become a breaking point. Some treaty member countries have already stated publicly that they support making the mining ban permanent rather than reviewable. The framework for keeping Antarctica protected exists. The question is whether the countries with the most to gain from resource extraction will agree to leave it in place when the moment of decision arrives. That decision is not being made in 2048. It is being shaped right now by who is building where, by which countries are deepening their presence, and by whether the international community decides that some places are simply worth too much intact to treat as resources. Antarctica is one of the only places left on Earth that functions precisely because it has not been touched. The ice cores only exist because the ice was left to accumulate undisturbed. The subglacial lakes only preserve their ancient ecosystems because nothing has breached them. The Southern Ocean food chain only works because the nutrient cycle beneath the continent has been running without interruption for millions of years. 22 years is not much time. The race is already underway, and the most consequential continent on Earth is the one most of the world has barely thought about. If this changed the way you see Antarctica, hit like and subscribe so you catch every video we put out. Turn on notifications so nothing gets past you. Here is what I want to know in the comments. If 2048 arrives and the pressure to open Antarctica to mining becomes serious, do you think the treaty will hold, or does presence win? And if you want to keep pulling at this thread, the next video covers another frontier under pressure right now. The story there is just as urgent.